Hello students, welcome back. In this video, we'll discuss about Einstein AB coefficient. If you remember, we have discussed about transition involved in laser in our previous videos. There are three ways in which atoms can exchange energy with the radiation field. What are those ways by which they exchange energy with the radiation field? They are absorption, stimulated emission, and spontaneous emission. Absorption, stimulated emission, and spontaneous emission. Here we have considered an assembly of atoms which is in thermal equilibrium. The incident light on this atom has the frequency nu. Let us have a look at the parameters that we have considered here. They are E1 and E2. E1 is the energy of the lower state and E2 is the energy of the excited state. N1 is the number of atoms present in the E1 state. N2 is the number of atoms present in the E2 state. Nu, as I have already mentioned, it is the frequency of the incident light. Nu, it is the energy density of the incident light. Now, when we shine light on these atoms, the atoms which are in the lower energy state, they will absorb this energy and they will move to the excited state. That is the E2 state. This process is known as absorption. Now, what is the probability of this absorption? That is, what is the number of absorption transition taking place per unit volume per unit time? So, this probability rate we have taken as TAB. Now, it is dependent on the number of atoms which is present in the E1 state, and since this is induced absorption or stimulated absorption, it is dependent on the energy density. So this TAB is equal to B12 N1 into U nu. What is B12? B12 is the Einstein coefficient of absorption from the energy state, from the lower energy state to the higher energy state. So this B12 is the proportionality constant. Now as soon as the atoms reaches the higher energy state, they emit radiation while returning to the ground state, and this can be done in two ways. One is a stimulated emission and another is the spontaneous emission. So let us first look at stimulated emission. The probability rate of the stimulated emission is given by, we have taken this as TST. It is dependent on N2, that's the population of level E2, and the energy density. Why energy density? Because the emission is occurring under the influence of the incident photon. So this is stimulated. So it is N2 into U nu. So this is equal to B21 N2 into U nu. What is B21? B21 is the Einstein B coefficient of stimulated emission of radiation. Now let us look at the spontaneous emission. The spontaneous emission, the probability or rate of spontaneous emission, we have considered this as TSP, that is dependent on the population of the level E2. So this is equal to A21 into N2. What is A21? It is the Einstein coefficient of spontaneous emission. Now we have introduced all the A and B coefficient. So let us just recapitulate. For absorption, the coefficient is B12. For stimulated emission, the coefficient is B21. And for spontaneous emission, the coefficient is A21. Now, at thermal equilibrium, the rate of the upward transition is equal to the rate of the downward transition. So we can write TAB is equal to TSP plus TSP. That is, the probability of absorption is equal to the probability of emission. This is all the emission. So if we put all the value of these probabilities, we get N1 B12 U nu, A21 N2 B21 N2 U nu. Then we solve for the U nu. We get U nu as N2 by A21 N1 B12 minus N2 B21. Now these can be rearranged as A21 by B21, 1 by N1 by N2, B12 by B21 minus 1. So we have rearranged this in this special way for some reason, because we'll be comparing it with some equation that I will tell you later. So this equation we have numbered as equation number 1. Now at thermal equilibrium, we have also discussed this earlier. The distribution of atoms among the different states is governed by the Boltzmann law. Boltzmann's law. So this is N2 by N1. If we take the ratio, this is equal to e to the power minus E2 minus E1 by kT, where k is the Boltzmann constant and E2 minus E1 is h nu, that is the energy difference between the two states. So e to the power minus h nu by kT. Now if we put the value of N1 by N2 that we require in the previous equation, so N1 by N2 is equal to e to the power h nu by kT. We have reversed this, so no minus sign, and we'll be putting it in equation number 1, where we require this, you see, N1 by N2. So putting this, we get U nu as A2 1 by B21 e to the 1 by e to the power h nu by kT B12 by B21 minus 1. Now, according to Planck's law of radiation, the energy density is given as U nu is equal to 8 pi h nu cube, nu is the frequency, by c cube, 1 by e to the power h nu by kT minus 1. Now, we'll be comparing these two equation, and if you see carefully, here we are going to find out the value of A21 by B21. If we compare this, we are getting this as equal to 8 pi h nu cube by c cube, and the value of B12 by B21, this will be equal to 1. So comparing equation 2 and equation 3, we get B12 by B21 as 1 and A21 by B21 as 8 pi h nu cube by c cube. So these are the coefficients A, B, the coefficient Einstein AB coefficient, and these are the two relation. This is relation number 1 and this is relation 2. Now, what is the significance of these two equations that we get here? So let us talk about the first relation. B12, we write here B12 is equal to B21. Now, what does this mean? This means that the probability of stimulated emission is equal to probability of this stimulated absorption, or simply absorption. That means these two processes will occur at equal rate. So, if you remember, so this denotes stimulated absorption. Sorry for this bad handwriting. And this is stimulated, I write it in short, stimulated emission. So that means these two rates will be equal. So that if these two are equal at equal rate, therefore no population inversion can be achieved in a two-level system, which means no laser can be formed in this two-level system. So for two-level system, we cannot get laser. At least we need minimum three level is required to have the lasing action. So this is the significance of this first equation. Now the second equation is, you see here, that A21 by B21, this is proportional to nu q. So let me just write here in the previous part, no laser for two level system, since no population inversion. I hope it is clear. Now let's move on to the this final part, A21 by B21, which is proportional to nu q. A21 is the spontaneous emission, rate of spontaneous emission, and this is rate of stimulated emission. So this shows that the probability of the spontaneous emission dominates over the induced or stimulated emission more and more, and as the energy difference between these two increases, the this dominance becomes much more and more, it becomes more and more dominant. So spontaneous emission is more dominant, sorry, is more dominant as the energy difference between the states increases. Okay, so these are the significance of the Einstein AB coefficient. If you like this video, subscribe, share, and hit the like button. Thank you all.